In this video, I'm going to show you how I would make up a problem for a student in linear regression. And this type of thing is really useful if you're developing your own algorithm. Why not make up your own problem for that algorithm to solve? In this case, it's linear regression. So let's go ahead and get started. So I will open up a new script file. And on this first line, I like to type in what I'll call it, and maybe, I don't know, demo line fitting .m. So I will copy this. I will go save as and paste in what I had copied. And now I have this program in memory, demo line fitting. And if I run it, I can see over here in the command window that it's running that. Okay, let's go ahead and get started. The very first thing I like to do in all of my programs is to initialize MATLAB. Initialize MATLAB. So I'll close any open figure window. I will clear the command window to the right, and the most important one is clear memory. I'm also going to hit return a whole bunch of times because I don't like typing on the last line in an editor window. And maybe the second line up here in the header, I'm going to remind myself the type of problem that I'm making up, and this will be a line. So it's an mx plus b. And so we want to come up with a bunch of random samples that we will fit to this line. So let's go ahead and dive into this with the first part of this, where we actually make up the problem. So I like a nice visual separation between the different sections of the code. Well, the very first thing, let's define the problem. So let's come up with a slope. How about 1.24? A y-intercept, how about 0.55? And feel free to make up your own numbers here, although maybe stick with these until this is finished to make sure your code works, but then feel free to make up your own numbers. And maybe we want to do this between x values 0 and 10. And number of points, how about 20 points? And because I'm strange, I like to line up the equal signs. I think it's visually cleaner, and clean code always runs better. I'm going to go ahead and run this to make sure that there's no errors. Okay, everything looks good so far. So at this point, we'll generate our 20 points. Generate, and we won't know that that's 20. We'll say n points. So first we'll come up with our x-axis going from xa to xb with n points. So we'll use the linspace command. We'll go from xa to xb with n number of points. And now if I run this and I type in x, I'll see the numbers go from 0 all the way up to 10. And if I counted, there'd be 20 points. I'll then calculate my line, y equals m times x plus b. And if I run this, and I can type in y, I'll see a bunch of numbers. Now, how do I know if this is correct? Well, I should plot this. Plot x comma y. And I'm not going to spend a lot of time dressing up this graphic. I will dress up the one at the very end, but right now I'm just testing to make sure I'm getting a line. And how do I know that that's the right slope? Well, I probably want to follow this with an axis equal to get the proportioning. And I know a slope of 1.24 should be just slightly greater than, 45 degrees, a perfect diagonal. And so that looks close enough to what I was expecting that I think that it's correct. Now, if I'm making up a problem, I'm doing discrete points. So first of all, let me just display this as discrete points, and I'm going to plot a bunch of red X's. Now, back to my point. If I am making up a problem, I'm going to want to add noise to this, right? Those would fit perfectly to a line, but I want to add noise. So here be my next step. Add randomness. And for troubleshooting, I like my random numbers to be the same random numbers every time. So I'm going to seed my random numbers with a 0. When I want to try it with different random numbers each time, I might either not have this line or just comment it out. All right. So I don't want my lines to go too crazy. So what I'm going to do is I'm going to calculate the distance between my points. And this is, I'm not saying this is something that's correct to do all the time. It's just what I'm going to do this time to sort of bound my noise. So I'm looking at the space between the points, and I want to use that as roughly my measure of distance of how much noise I want to add. So then I'm going to say x equals x plus, and then I'm going to add the noise. So if I type in rand 1 comma n, this is going to give me a list of, in this case, 20 random numbers going from 0 to 1. But you know, I might want to add and subtract. So rather than go from 0 to 1, what if I subtract 0.5? Now what I've just put in parentheses is a random number from minus 0.5 to plus 0.5. Well, that doesn't use information from dx. So what if I multiply this by dx? Now I'm saying x plus or minus half of that spacing between the different x values. And I might find that's probably not enough randomness, but it does roughly bound it. So I might want to just multiply it by a number like 5. And I also would likely want to add randomness to my y value. So I'll stick with the same amount of randomness, but just type in y. So now I've added randomness to x and y. Let's go ahead and plot that. And hey, you know what? That looks like a pretty good random smattering of points that could be a question. And so then what I might do is even make up a column vector of the numbers. And if I run this, I can go here and there's all my numbers. And then what I might do is copy and paste this into a homework assignment. Maybe even eliminate a few of the decimals just to clean it up and say, fit those to a line. So we've made up a problem. And so from this point forward, we're going to forget that this is what we started off with. All we have is our samples in x and y. And to sort of enforce that, let's clear everything else from memory. So we're going to clear the slope that we defined, b. We'll keep xa and xb because that's defining the problem. We'll clear n, and we'll clear dx. Pretty sure that's all we made. And we'll run that, and that's it. We now have only an x and y in memory, which has noise in it that we need to fit to a line. And that's where we'll pick up in the next video.